Hello, my name is Alex Hardesty and I work in the School of Computer Science and Informatics at Cardiff University in the UK. I'm also a member of the DISCO technical team, where I contribute to the design of the DISCO research infrastructure, the distributed system of scientific collections. Today, I'm going to talk about extended digital specimens on the Internet. The publication in 2017 of Michael Webster's book on the extended specimen in the context of developing bird collections catalyzed new thinking for us in Europe, in DISCO, on the means for building digital collections. This thinking is based on the idea of open digital specimens that are findable, accessible, interoperable, and reusable. By that I mean fair. In the USA, the book led to proposals for an extended specimen network as a strategy for US biodiversity collections, promoting their importance in research and education. Again, strongly reliant on mass digitization and on the Internet. Successive and multiple ongoing conversations between these initiatives and others led eventually in 2021 to an intensive global consultation under the sponsorship of the Alliance for Biodiversity Knowledge and GBIF. This consultation, just completed, was about converging all ideas towards the digital extended specimen and the major steps that must happen to make it real. I want to give you a flavour of that future. The outcomes of the consultation will be reported in full at the forthcoming TADWIG 2021 conference in October, where you'll also be able to hear a keynote talk by Mike Webster on how the digital extended specimen can enable new science and applications. Our thinking begins with identifiers for everything. The idea that digitized data about a specimen is always published with a unique and persistent identifier, a DOI for example, that not only identifies the open digital specimen unambiguously, but which also sets and maintains an unbreakable link to the hard evidence that is the physical specimen in a collection. I won't explain the technical mechanism today, except to say it involves binding authoritative information such as the identifier of the physical specimen itself and that of the curating institution with the DOI. This should be sufficient to find the physical specimen when it's needed. Once created, the digital specimen is acting as a kind of surrogate or twin on the Internet for the specimen in its physical collection. The digital specimen can be processed. Of course, digitization means different things to different people, so we're presently working in TADWIG to specify the minimum information to be expected to come out of different levels of digitization activities. This is the new minimum information about a digital specimen or MID standard, coming soon, that some of you have already heard about. DISCO is also working on and proposing a new standard for open digital specimens, OpenDS. You can see that idea illustrated in simple form here. This standard provides us with a digital representation for the Internet that is actionable and fair, meaning that it's findable and usable by humans, but more importantly, it's understandable and processable by computers and scalable for the hundreds of millions of digitized specimens and the transactions involving them. So far, so good. A further idea from our thinking exploits the expert social power of the community as a whole to collaborate, create, and contribute. It also exploits the automation power provided by machines. Together, these help us to massively enrich and extend the information around specimens, using new tools that will emerge over the coming years. You can see hints of this already in tools like David Shorthouse's Bionomia that links natural history specimens to the world's collectors, or in the award-winning work by Nicky Nicholson on revealing hidden links between specimens in different collections. A new generation of tools will come from the recently started Bicycle project for reusing embedded data extracted from taxonomic literature. There are also new services being planned and developed by DISCO, a specimen data refinery with the potential to harmonize and automate common digitization tasks into workflows, and a community-orientated curation and annotation system, not forgetting, of course, the loans and visit systems already operational in its first phase. With a transaction-orientated approach, recording enrichment and extension events on digital specimens will allow provenance to be maintained, work to be properly credited to the individuals responsible, and trust levels in fair data to be elevated. As well as automating linkages to external data in GBIF, GenBank, Catalogue of Life, Wikidata, and more, as highlighted here, Open Digital Specimens will allow new supported operations to be defined and executed on demand. Operations such as linking specimens together semantically, meaning with characterized relationships such as is part of or is holotype of, is paratype of, for example. Adding annotations, retrieving deposited sequence data, or extracting features en masse from multiple specimens, to give but a few examples of the possibilities. Actually, these kinds of operations are already possible and demonstrated today. Imagine being able, in a standardized way, to invoke an extract features operation to automatically mark regions of interest, leaves, stems, flowers in this case, and to make some trait measurement, such as leaf area, across hundreds of thousands of images, no matter where in the world these images are stored, even across multiple collections, without the need to find and bring all the relevant images together in a single place for processing. A small amount of AI machine processing capability in each location, an extended specimen server, if you like, makes it possible to do this, just like a mail server in each location makes email possible for you today. With their own personality and life cycle on the internet, open and extended digital specimens incorporate these three ideas that I've explained. Extending the digital representation of a specimen, making this representation machine actionable and fair, and driving and supporting changes in working practices with new standards, software and tools. Open and extended digital specimens are a new kind of data as infrastructure that helps us to solve systemic problems our community faces. In an era of modern data-driven science, the existence of multiple heterogeneous collection management systems of varying capabilities, and the almost complete absence of linkages between digitized vouchered specimens and between these specimens and the secondary data derived from them is a significant barrier. We're hindered to properly answer contemporary scientific questions for the world's challenges today. And these difficulties are compounded by the approximately 3 billion specimens being stored in thousands of collections around the world, and by the increasing difficulty to scientifically curate across taxonomic groups, especially for smaller institutions. The power of the community is needed. There are many questions that it's impossible for me to answer in this short presentation. In DISCO, we've been designing and planning for several years already. Pilot services are coming soon. And now, an international group of nearly 50 experts from around the world, jointly led by iDigBio, Beacon, DISCO, and GBIF, is shaping this future. I hope you find this inspiration for the next decade of digitization as exciting as I do, and as they do. It's a challenge for this community to achieve. It's our let's go to Mars moment, if you like, where we must all converge and proceed together as a partnership with common direction if we're to make this a success. What's needed next? I suggest we need a beta version of the new OpenDS standard with at least 2 working implementations alongside it in the first place. Coming together to adopt a single global persistent identifier scheme based upon DOIs with a common open digital specimen metadata is critical to make things fair. A strong global collaborative partnership with coordination of the essential engineering is necessary to achieve these steps and to make them useful for value-added tools and services to build on top. Harnessing and steering developer resources towards this goal is essential. Thank you.